Okay, let's start from the question which I'd given you yesterday, and that was the vessel is suddenly listed at sea. So, what is the step-by-step answer that you have to write for it? Because this comes as a 20-mark question. It's a theory question for 20 marks. So, the first step that you have to do is basically you have to inspect all the holds and cargo lashings. You have to inspect all of them, and basically you are checking for any shifting of cargo. That's the first and foremost thing that you have to do. Next is you have to sound all the liquids in tanks. You have to take the soundings of all the liquids in tanks. And now soundings when we are taking, which all soundings that we are doing. So we are taking soundings of all the bilges, then water ballast tanks, freshwater tanks, fuel oil tanks, diesel oil tanks, oil tanks, all the cofferdams, all the void spaces. Anything left for taking soundings?
fuel oil tank.
फ्यूल ऑयल लिख दिया,
Sir, bilges.
बिल्जेस भी लिख दिया. So bilges, water ballast, fresh water, fuel oil, diesel oil, lube oil, cofferdam, void spaces. So basically, we have covered up all the possible this thing. Again, if you can think of some more, you can add that to the list. So you sound all of them. What is the purpose of sounding this thing? You will now calculate port and starboard distribution of weights. So basically, what we do is we calculate the port side distribution of weights and the starboard side distribution of weights. Right? You calculate port and starboard distribution of weights. You also calculate the stability of the ship, stability of the vessel. Now, when you calculate the port and starboard distribution of weights, you will find mostly the weights are equal. So, I forgot one point when we said inspect all holds and cargo lashings, and we said sound all liquids in the tanks. Before that, we have to stop all operations basically. And so, with point number one, I can write stop all operations on board. That that has to be the primary first one. And along with that, inspect. You can make that as point number one together. Stop all operations on board also means that if if my vessel is at sea, then I need to stop the ship. That is also stopping the operations. I need to stop the ship. because as I keep progressing along, this list or heel is going to keep on increasing. So it means stopping the vessel also, taking a shelter and stopping, obviously. So once you calculate port and starboard distribution of weight, you will find them equal, right? That means the list is not due to unequal distribution of weight, because that is the reason for checking this. Calculating stability of the vessel means we are calculating the GM of the vessel, basically. So now at this stage, you will find, since the GM of the vessel is found to be negative, hence vessel is at angle of lol. And generally, how do you find that? How do you come to the conclusion that the vessel is at an angle of lol? One, GM is negative. Second, very standard feature, we know that, is GM solid minus FSC gives me GM fluid. So the moment FSC will exceed GM solid, you know that you are at an angle of lol. That means FSC is greater than GM solid. This means vessel is at angle of lol. The free surface will be greater. And free surface greater means the free surface moment is greater. So the I is greater. That is how it happens. Okay. Next, since vessel is at angle of lol, we now need to take corrective actions for angle of lol. So the first action that we need to take is we need to ballast all centerline tanks first. सबसे पहले हमें centerline tanks को ballast करना है. Why ballast centerline tanks first? Because they're not going to add to the list. Point number one. That is the first and foremost thing. The other reason for ballasting centerline tanks first. Why? So, point number 8. Why centerline tanks first are ballasted? Why centerline tanks first are ballasted? So the answer to this question now, because by ballasting, the W will increase, the displacement will increase. This is the answer. The displacement will increase. When displacement increases, as a result of that, Km will increase. If Km increases and I'm ballasting centerline tanks, the Kg will be going down. So Kg is going down, Km is going up. That means the GM has a tendency for going positive. There is a tendency, does not mean it will become positive. So as a result, a positive righting lever is created. Since a positive righting lever is created, this will lead to a reduced angle of lol. This will lead to a reduced angle of flow. That is the reason why we ballast the centerline tanks first. And of course, the centerline tanks don't add to the list. That is the standard point. But this is a technical reason.
Sir, why the KM will increase?
Displacement is directly proportional.
Okay. Okay.
Displacement directly proportional. On your in your hydrostatic particulars, if you go K of your hinge shape, the you see that column draft increase, displacement increase, and then Km increase.
Yes.
So therefore,
Excuse me, sir.
Anji,
Let's see if we are fully loaded, then in that case, we'll do the same.
absolutely right.
Okay, sir. Thanks.
You have to try and understand one thing that when you are fully loaded, generally, a fully loaded vessel, um, you will not be having that much of slack tanks. Okay, so this is generally it happens in partly loaded vessels when you have part ballast and part cargo. तब ये ज्यादातर होता है. But I'm not trying to say कि fully loaded में नहीं होता है. I'll give you later examples of that also. वो बाद में मैं दूंगा. But I'm just generally saying that.
Okay, sir.
Now we ballast the centerline tanks first. Now next we need to reduce the free surface effect. How do we do that? We do that by we press up all slack tanks to make them full. To make them full. And this operation, please remember, is done one tank at a time. One tank at a time. All our tanks are not opened up. We press up all slack tanks full to make them full. One tank at a time. Once you have done that, so basic idea is to remove the free surface. That free surface was the one which was causing the problem. In 90% of the cases, at this stage, the moment you remove the free surface, the vessel will become upright. 90% of the cases, this is the main cause. Slack tanks. Then, having done that, and
Sir, won't this point come before the previous one?
no, this won't come before. This won't come before. Having done that, we still are on a reduced angle of flow. So we will ballast. Now we have to start the ballasting. So ballast lower side, lower I moment of inertia tank first. Ballast lower side, lower I tank first. So in a typical case, lower I means I moment of inertia is LB cube. So I is directly proportional to breadth cube. That means lower I means lower breadth, small breadth. So in our case of a ship, it will be generally DBT 1, port or starboard. So this lower side means starboard. So I'm ballasting lower side, lower I. That means number one, tank first. Now the question is why? Why do we ballast lower side, lower I tank first? So let's write the answer to that. Why do we ballast lower side, lower I tank first? So basically, what happens is when we ballast one starboard, that is the lower side and lower moment of inertia. So there are two things which are happening. One, I'm ballasting. So when I'm ballasting, all of this is happening. All of this is happening. So all the points of point number 8 are happening. That means my displacement is increasing, my km is increasing, kg is going down, a positive writing lever is created. So all the points of number 8 point happen. Once this happens, a positive writing moment is created. This positive writing moment will be W, that is the capital W, the displacement, into the writing lever, that is nothing but GZ, so many ton meter of positive value is created. Displacement into writing lever is created, which will now simultaneously there is a listing moment also created, which listing moment which is created will be W into D. Small w is the amount of weight that I'm adding in the DB1 starboard, and D is the distance from center line that is causing the list. This listing moment will tend the vessel to make it go more on starboard because I'm ballasting starboard side. So this will be a negative value because it's taking me away from upright. So I have got a positive writing moment, I've got a negative listing moment. That is what is happening. Now, the positive writing moment is far, far greater than the negative listing moment. Do you agree with the statement? Why? Because this capital W is my displacement of the vessel, 1,75,000, that kind of a figure. So 1 lakh multiplied by a small answer is still going to give me a very high value. This small W is hardly 300 tons, 500 tons, multiplied by whatever, 10 meters, 15 meters. is going to be a very small value. So this value will always be far, far greater. So therefore, the net resultant is a positive writing moment which is reduced, but it is still there. Positive writing moment, negative listing moment, the resultant is going to be still a positive value. And therefore, this will lead me to a reduced angle of flow. ये समझ आ गया सबको?
ये
Is
बताना
this
सर,
okay
एक
with you?
मिनट। पॉजिटिव राइटिंग मोमेंट इज इक्वल टू डब्ल्यू इंटू जी जेड। डब्ल्यू इसमें कौन से वाला है सर? टोटल जहाज की
ये
डिस्प्लेसमेंट।
बिल्कुल ठीक।
ठीक है सर।
ये कैपिटल W है, ये छोटा w है, which is the weight being added.
ये पॉइंट नंबर 10 एक बार समझाएंगे? ब्लास्ट लोअर साइड लोअर आई।
वही तो बता रहा, यही तो सारी कहानी वही चल रही थी कि you have to ballast the lower side lower I tank first, because हमारी शिप की शेप ऐसी होती है कि जो आगे का टैंक होता है वो नैरो होता है, उसकी ब्रेड्थ कम होती है। अगर उसकी ब्रेड्थ कम होगी तो उसका मोमेंट ऑफ इनर्शिया भी कम होगा, बिकॉज आई इज एल बी क्यू बाई 12.
ओके सर, ओके।
So this will lead me to a reduced angle of roll. Since I am on a reduced angle of roll, now basically this is what I wanted to achieve. Now counter this. What if I had ballasted one port first? What would have happened? What would have happened? Had I ballasted one port first, so my positive writing moment, my positive listing moment, so both would have been positive. Since both are positive, both would have landed up on this side. And if both would have landed up on this side, my vessel would have crossed over onto the port side. And now it would have been going to the angle of lull on the port side. And in this process, she will gain momentum. And if she crosses that angle of lull further, it will turn into a capsizing moment. So a capsizing moment gets transformed and the vessel can collapse on the other side. That is the reason why we don't ballast DB1 port.
जिस साइड लिस्ट है सर, बस उस साइड के स्मॉल ब्रेथ के टैंक को पहले लोड करना है, मतलब ब्लास्ट करना है।
Pehले ballast. That is the reason. All right. Point number 11. Having done that, next we ballast the pair tank, that is DBT 1 port. Now that you are at a reduced angle of lull, you can ballast the pair tank, that is 1 port. You have to make the weights equal, port and starboard. Since you have to make the weights equal, so you ballast the pair tank. Now the capsizing moment won't develop. And continue ballasting. Continue ballasting with next set of tanks. one tank at a time, of course, till vessel becomes upright. If vessel still not upright, then you have to consider jettisoning of cargo. Then you have to consider jettisoning of cargo. How do you jettison cargo? Jettisoning of cargo. Here we are basically assuming vessel is a log carrier. That means we've got logs on deck, supposing. Generally, it's the log carriers who go to an angle of flow. Generally, I'm saying.
Excuse me, sir. Can you adjust the camera, please? We could not see the upper part of your board.
You just have to anyway. चलो fit to screen कर दो तो हो जाएगा. Can you see this? Can you see the board now?
Yes, sir. Now it's okay. Thank you.
Assuming the vessel is a log carrier. Now, generally, it's the log carriers who go to an angle of flow. Generally. So, therefore, you will consider jettisoning of logs. Now, when you're doing jettisoning of logs, you will first calculate exact number of logs required to make vessel upright. You will calculate the exact number of logs required to make the vessel upright. So first you do that. Then you will be jettisoning the logs. Jettisoning of logs will happen from the higher side. You will be jettisoning from higher side. That is, in this particular case, port side. And the reason is very clear. You know the reason. Because if you discharge the cargo from the higher side, from the port side, the G of the vessel will shift in a direction opposite. That means it will shift lower side. It will go down. And once the G goes down, then all those points of point number 8 will happen. That is, a positive righting lever is going to get created. So therefore, this jettisoning process is a very tricky process. Jettisoning of logs is done using, you use chain blocks. It is done by slackening the required lashings, slackening of lashings. You use crowbars, snatch blocks. You use snatch blocks. So you use chain blocks, you slacken the lashings, you use crowbars, You use snatch blocks, and you generally do one log at a time. You do one log at a time, and you just slide them off the vessel on port side. So this is a very tricky operation on a log carrier, because when you're doing that, these logs, when you slide one log, उसके साथ में एक दो और चले जाते हैं. So it's a very slow process, and it's a very time consuming process. It can take as much as 12 to 14 hours. Sometimes it can even take 24 hours. It's a very, very tight, tricky process. And you have to make sure, do not use ship's cranes. You do not use ship's cranes or derricks. Do not use them. Because if you use the ship's cranes or derricks, then the G of the ship, the G will shift up and the GM will go down. So we don't do this. If for some reason vessel is alongside, then we don't jettison cargo, then we discharge cargo using shore crane. If vessel is alongside, then we discharge cargo using shore crane. Any doubts up till now?
No, sir.
Okay. Uh, some vessels, some vessels which can go to angle of loll are as follows. These are some of the ships. So one is log carriers. I told you that they very popularly go to an angle of loll. Very, very frequently. They go to an angle of loll. Roros are also considered as very, very popular to go to an angle of loll. Passenger ships go to an angle of loll. Certain Suezmax tankers were found to go to an angle of loll. And very recently, these large LNG vessels, the large ones, they have also been found to go to an angle of loll. These are some of the vessels which go to an angle of loll. Log carriers I've explained to you just now, because the logs are loaded on deck. So therefore, deck pay, because these logs are loaded, so they absorb moisture and they gain weight. That is how these log carriers, and because the weight is increased on the deck at sea, so as a result, the kg increases the GM goes down at sea. So that is the one of the reasons why it happens. One of the another reason why it happens is these log carriers are inherently very low GM ships. So जब वो सेल आउट करते हैं पोर्ट से तो उनका जीएम वैसे ही इनहेरेंटली बड़ा लो होता है 0.18 0.19 इतना होता है and if your freshwater consumption and your bunker consumption is high so at sea they will go to an angle of low very frequently these log carriers there's a big major problem with them so if you ever go on a log carrier as a mate be very careful ro ships ro because by virtue of the cargo so if your cargo is loaded on the top deck and your bottom deck is all empty thanks to the port rotation. I forgot container ships. I'm sorry. I forgot container ships. They're very prone to container vessels, container ships. So what happens in container ships is due to port rotation of the containers. If the fully filled cargoes are on the top on the open deck and the empties are down below, then due to the port rotation basically, then your kg is naturally high and therefore the GM of these vessels is very low. So these container vessels also, due to the port rotation, they have a tendency to be on low GM or go to an angle of flow at sea. Ro-Ros have discussed container ships. Passenger ships. Passenger ships, basically, the tendency of these vessels is you've got passengers on the deck. All the passengers want to go on the sun deck. So all the passengers go up. The kg of the vessel rises. The GM goes down. So how do they control that movement of the passengers? Any idea? How is passenger vessel? How do they stop this passenger vessel from going to an angle of flow? Make a guess.
सर डेक वाइज क्लियरेंस होती होगी हर पैसेंजर की
Correct. Absolutely right. Absolutely right. Access control, it is called. Access control. So passengers from lower deck can only go one deck up. Cannot go or everybody cannot go ऊपर. नहीं तो सारे के सारे ऊपर सन डेक पे पहुंच जाएंगे. So access control. Passengers from top decks can go down. Passengers from bottom decks can only go one deck up. So access control करते हैं वो लोग. So you have access control. Your card will only be able to slot you for going one deck up. That's it. Same story goes for port and starboard also. Because when the passenger ships, when they're touching port, generally, what will happen is everybody wants to go on to the side where the jetty is. So it's a very standard problem with them. तो सारे के सारे पैसेंजर्स अगर स्टार्बर्ड साइड जा रहा है अलॉन्ग साइड तो सारे के सारे स्टार्बर्ड पहुंच गए तो जहाज तो वैसे ही लिस्ट कर जाएगा सो दे हैव पोर्ट टू स्टार्बर्ड एक्सेस कंट्रोल आल्सो so access control is going up vertically and port to starboard as well so they control that so that's how the passenger vessels control this. There was one very famous accident, passenger vessel accident, which took place way back. Way back, it was a South Korean ferry. uh, and she sank at sea. South Korean ferry. She was ferrying school children, and they had gone out on a cruise, on a day cruise. The name of the ferry was Suol, Suyol, Suol, and at sea, which while she was cruising, same thing happened. Basically, uh, all the kids must have gone on to one side. She was a big one. She was a big ferry, and this ferry collapsed at sea. She just tilted over, healed, and everybody, some 450 odd South Korean kids had died at that time. Uh, it was a major, major calamity disaster which took place. And it was a big news in the international. Even now, you can go onto Google and type Seoul ferry disaster. Big news at that time. The South Korean Prime Minister had to resign. So that was the news at that time. So, so that is that with regards to passenger ships. Suezmax tankers. Anybody knows the history behind this? Suezmax tankers. Tanker guys. इनकी क्या प्रॉब्लम है? Suezmax tankers. So Suezmax tankers के साथ में एक इशू ये था कि the the centerline bulkhead in the DB, in the water ballast tank, what they did was during in the 90s जो जहाज बने, some of them they did not to save money. कई टैंक्स में तो इन्होंने ये सेंटर लाइन डिवीजन डाला ही नहीं, और जिसमें डाला वो पूरा नहीं डाला. एज अ रिजल्ट जब इनको हम बैलेंस करते थे, the moment the water would cross here and over here in this region, the full beam, full breadth was exposed, LB cube by 12. So moment of inertia was the greatest. And if at that time my cargo level was slack, then double effect used to happen. So these vessels, when you were loading the cargo and you were simultaneously deballasting, the moment the water ballast would cross this and come down, these vessels invariably went to an angle of roll alongside while loading is going on. And a lot of accidents took place in these Suezmax tankers. So in the next dry dock, what was done? This was called as a U-tube effect. This, in the next dry dock, this was welded right up to the top. So it was U-tube was converted into a J-tube. And that is how they circumvented this. But some of the vessels with this are still prevalent today, and they put only experienced mates on these ships. So the trick basically is the tank where you're loading, you don't deballast those tanks. So there are various methods for it. Either the tanks which don't have a centerline bulkhead, you deballast them first before you come alongside. उनको पहले ही deballast करके रखो. That's the trick. So that at that time you don't have to do it. And in case there is an air draft problem or restriction, then you do the other way around. That is, if I'm loading in number 2 cargo oil tank, then I would be deballasting number 4 or number 3. I will not be deballasting number 2. That is the trick which is played. So you have a particular sequencing, and you only follow that sequence. So only experienced mates are put on these ships. Suezmax. You have to be careful because you have to know the sequence of deballasting. So that is how the Suezmax tankers problem was eradicated. And the last is the LNG. This problem came up few years ago. These LNG vessels, while alongside, also the same story happened. The while loading and the deballasting was on, the mate was not experienced. He opened up all the tanks for deballasting. So free surface was generated. It reached such a high point that the LNG vessel, while alongside at the terminal, went to an angle of lull. Chickson parted. Lots of dhamal happened. Lots of chaos. So again, that's the reason for putting very experienced mates on these LNG vessels, these large ones. This problem doesn't occur on small vessels. It occurs only on large LNG vessels. So that's that with regards to the Hanji. Any doubts?
Yes, sir.
Hanji.
Your point number 12 जो है सर कंटिन्यू ballasting with next set of tanks, one tank at a time. So इसमें हम same procedure सर follow करेंगे. First we will ballast starboard side,
So
two starboard.
one के बाद two starboard के बाद two port.
Same procedure. Okay, sir.
Same
Okay, thanks.
Any other doubt?
सर ये जो आप कह रहे थे एफएससी जो एलएनजी में आया था because all tanks were open, the same we do on oil tankers also ना, sometimes we load all 6 tanks together. तो सर उसमें क्यों नहीं होएगा फिर?
Oil tanker में see what happens in oil tankers is the size of the tank is small. It is not very large because the breadth is small. It's divided, right? So I've got either across tanks or I've got wing tanks.
Okay.
Right. So since I've got since my breadth of the tank is small, so that is the issue. It does not happen on these tankers.
Okay, so LNG does not have that center partition of the tanks, is it? Okay.
No, that is not. LNG doesn't.
So regarding jettisoning of cargo, in case of log carriers, it's possible not to use crane, but if other type of ships, then how to manage?
Then you cannot. So you cannot jettison cargo on a container ship for sure. You cannot jettison cargo on a general cargo ship. You can only jettison if you have deck cargo, number one, and you've got the capability to jettison. You should have the capability to jettison, na? Log carriers में you can jettison, but बाकी cargos में you cannot. Quite
Okay.
obviously.
So only log carriers we can do that.
Log carriers. Because I have sailed on one log carrier in my entire life as a second mate, and that only the every trip we used to go to an angle of log. That was a very dumb thing. So that's the process that we used to follow, because these ships, they inherently, we used to load in Malaysia, Indonesia, and we used to discharge in Taiwan, China, and Japan. We were on a Taiwanese charter, and it was a standard problem. Load kiya Indonesia, Malaysia में, we used to load in Miri, Sarawak, and all these places, river ports. And the moment you load and you sail out, we used to sail out with 0.18 GM and all that. And if for some reason your freshwater consumption shot up, your freshwater generator could not cope up. Invariably, by the time we used to cross Philippines, and बस वहीं से शुरू हो जाता था हमारा रोना. It was a standard thing कि जहाज एंगल ऑफ लॉल पे जाएगा. So we used to perpetually take shelter of Taiwan, Taichung, or all these places. We used to drop our anchor there, do this entire operation. Sometimes 10 logs, sometimes 12 logs, sometimes 15 logs, jettison them, become upright, then sail out. So, first time it was a very scary thing. पहली बार जब देखते हो तो जहाज पूरा का पूरा ऐसे ही डांस किया हुआ है, 25 degrees on the starboard side, listed. You're thinking you're just going, but you're not going. You're still there. And the moment you discharge the logs, ठक करके upright आ जाता था जहाज. So it was like magic. That's how we survived. And that was the last time I went on a log carrier. I never went after that. I switched over to tankers. I said, might as well भाग लो यहाँ से. So we never had any of these problems in chemical tankers thereafter. But these problems are there in these log carrier ships. Anybody has faced angle of lol at sea ever? I don't think so.
No, sir.
बच गए. So on these container ships, you got these anti-heeling tanks also. So
Yes,
so that is the advantage you have that today of anti-heeling tanks. So one can automatically correct it. Okay, so I want you to do exercise 19 of your chapter. There are 6 questions given there. Please attempt those questions, the numericals. Exercise 19. Question number 5 and 6 are identical to question number 15 that I had done. So of the first chapter, the angle of lol wala. So question number 5 and 6 is identical to that. So please do these 6 questions. Okay. And tomorrow we shall start with the Simpson's rules. कल Simpson rules शुरू करेंगे. ठीक है? From the same book only we'll be doing. That's a big topic and that's our 30-mark question. वो 30 marks का आता है. Sure shot. So उसको तो क्रैक करना ही है हमने. All right. See you then tomorrow. Bye.